In this video, we're going to look at the physics of motion. There's some key vocabulary we'll cover: distance, position, displacement, speed, and velocity. So these are all words you've probably heard before. Some of them have more specific definitions when it comes to physics. And we'll come back to these words at the end of the video. The first question is, how can we describe the position of an object? Because that's really what physics of motion is trying to do. It's trying to describe where an object is or how an object is moving. And usually we do that mathematically. Let's draw a little picture here. So we'll draw a little person here, and we'll have them move 2 meters. So now they're over here. Okay, so this would be called their initial position. Position is x. That's what the symbol we use for position, and we'll put a little I down there for initial. Maybe I'll write initial for now. That's the x initial, and this is the x final. So how would you say their final position? If you just say they're 2 meters away, well, that doesn't tell you anything about the direction, about where they are. They could be 2 meters to the left or 2 meters behind or in front, but they're 2 meters to the right on your screen. And when an object is moving to the right, we usually say it's moving in the positive direction. So we'll say it's positive 2 meters. Their position would be positive 2 meters. Okay, sometimes we also use the directions on a map, so north, south, east, and west. So for our drawing here, we could have said 2 meters east. And if we are going to use these coordinates, the convention is that east and north are positive, and south and west are negative. And another question that we would ask is, how can we describe the motion of an object? So if we come back to our drawing here of the little person that moved positive 2 meters, and their final position is over here. Let's say it took them 1 second to move that 2 meters. Then their speed would be the distance, 2 meters, over the time. And we said that it took them 1 second. So in this case, it's just 2 meters over 1 second. Their speed is 2 meters per second. Now notice that by saying the speed is 2 meters per second, that doesn't tell us anything about the direction that the person is moving. If we wanted to say that they moved 2 meters in the positive direction, and we wanted to talk about how they're moving, we might use the term velocity. And velocity is actually a little bit different than speed. Velocity includes a direction. Even though in everyday language we usually say speed and velocity interchangeably, velocity is actually the displacement over time. Displacement over time. And displacement is the change in position. So in this particular case, it was positive 2 meters over 1 second. So the velocity would be positive 2 meters per second. So notice that the number is the same. It's, in this case anyways, it's still 2 meters per second, but velocity means that we're going to have a direction associated, a positive sign in this case. Okay, let's look at this picture here, and this will help clarify the difference between distance and displacement. Let's say we have a runner that's going to run the 400 meters, and they start right here on the track. This is a 400-meter track. That's your standard track. Okay, after one lap, what is the distance they've traveled? Okay, well, the distance would be 400 meters. Okay, so distance, and the symbol for distance is d, small d. Distance is 400 meters. Now, what is their displacement? Well, displacement is their final position minus their initial position. It's the change in position. I'll write this down. Displacement, symbol for displacement is also small d, but it has an arrow over it. And this arrow just indicates that it has a direction associated with it. So displacement is equal to the final position minus the initial position over, that's it, final position minus initial position. If they ran one complete lap, then they're running right back to where they started. So their displacement would actually be 0. The final position is 0 meters. Initial position is 0 meters. Obviously 0 minus 0 is 0 meters. Okay, so there can be quite a difference between the distance and the displacement. Let's say they ran halfway across the track. So then they'd be over here somewhere. Their distance would be 200 meters. Their displacement, well, to find out their displacement, we'd have to find out how far away they are from where they started. And you'd have to take a measuring tape and measure this right here. That would be the displacement. Okay, so let's just review those terms that we had before. Distance just means the ground covered. Position, where an object is. Displacement is the change in position. So let's just look at the symbols here too. The symbol for distance is small d. Position is x. And quite often we draw a little arrow over it, again, just to show that it has a direction associated with it. Displacement is the change in position. So displacement would be the final position minus the initial position. That's equal to the displacement. And the displacement is a small d, but it has an arrow over the top of it. Speed is distance divided by time. Speed is v, so that's d over t. Velocity is v with an arrow over it, again to indicate it has a direction, and that's displacement over time. So displacement over time. Now we've been talking about terms that have a direction associated with them or don't, and there are some fancy words for these. A vector is something that contains both the magnitude and the direction. The magnitude would be like the number. So for example, let's just say 35 kilometers per hour east. Okay, so if we give it a direction, if we say it's east, then it's a vector. So this would be velocity. Velocity is a vector. Displacement is a vector. So if we say something has a position of, let's say, positive 20 meters, that would be a vector because it has a direction. Displacement is a vector. Also acceleration, which we haven't talked about yet, but acceleration is a change in velocity. That's also a vector. A scalar means that it only is the magnitude and doesn't have a direction. So if we just said 35 kilometers per hour, that would be speed, and that would be scalar. Also, if we said just 20 meters with no direction, that would be distance. So speed and distance are both scalars. Okay, let's put all this together and try to answer this question. A person walks 2 meters east. 2 meters east. Then 3 meters west. In 5 seconds. Okay, what is their distance traveled? Well, they went 2 meters one way and 3 meters the other way. Their distance traveled is 5 meters. Distance is never going to be negative. Doesn't matter which direction this person is traveling, their distance keeps accumulating. Okay, their displacement, however, that means their final position minus their initial position. Well, their final position is 1 meter left, or negative 1 meter from where they started. So this is negative 1 meter minus their initial position, and we'll just say their initial position was 0. So their displacement is negative 1 meters. That's how far away they are from the origin. Now the question's asking for their average speed. Well, speed is distance over time. Their distance, we said, is 5 meters. The time for this journey was 5 seconds. So their speed is 1 meter per second. And by the way, you're not supposed to write equal signs one after the other in the same row like this. I'm just trying to save space. Okay, so D, average velocity. Well, velocity, we said, is displacement over time. Well, what is their displacement? It's up here. We said their displacement was negative 1 meter over time, and the time is still 5 seconds. So negative 1 divided by 5 is negative 0.2 meters per second. Okay, so it might seem a little strange to you that you have a negative velocity, negative 0.2. But it makes sense because our displacement is negative. So you can have a negative velocity. You cannot have a negative speed. You can have a negative displacement, but you can't have a negative distance. Okay, we'll do some practice questions in class to help you with this.